Hey, pre-calculus, welcome to the next part of this grand handout number 9. We will be going over the finer points of the unit circle, at least the angles and the x and y coordinates that go with them, i.e. the cosine and sine values associated with these reference angles that we've been speaking about right here. Alright, so first off, we got to establish a few angles. You know, where do these angles come from that we were looking at before? So first off, we look at this right triangle. We're using legs of length 1. And we said, once again, it is a right triangle. And it is isosceles. So that means that this angle and this angle are exactly the same. All right, so let's go ahead and highlight those the same color. And then we've got our hypotenuse hanging out here. We'll just call it R for right now. We're going to go ahead and try and figure out what R is. Remember, R squared equals A squared plus B squared. Where R is it's the hypotenuse, right? It's the C part. All right. And so what is A and what is B? Why, they are both 1. All right. So we're going to plug that in. We've got R squared equals 1 squared plus 1 squared, which of course is going to be 2. And so what is R? R equals the square root of 2. So there it is. We've got it, the square root of 2. All right, so we've got that length. We don't have all the information we're looking for, though. Let's go ahead and figure out what these angles are, these alpha angles. The sum of any of the angles of any triangle are going to be 180 degrees. That's pi radians, right? So 180 degrees, that's the same as pi radians. And that's, our angle alpha plus this guy. That's 90 degrees. That is pi divided by 2. So we're going to go ahead and solve this for alpha. Right, subtract pi over 2 from both sides, and that equals 2 alpha. Solve for alpha, and we get alpha equals pi divided by 4. Now that is the same thing as 45 degrees, right? That's our first angle. That's 45. Let me go ahead and rewrite that. That looked a little ambiguous. There we go. That's better. 45 degrees. All right, so that is our first angle, right? This was 0 or 2 pi. And then we've got 45 degrees, our first angle that we're looking for. That is pi over 4. All right. So let's go ahead and continue working on this one. We've got we know that if we go out 1 and then we go up 1. And we want to know what is cosine and what is sine. All right, so what is cosine, what is sine? So the cosine of alpha, well, what is that? That's the opposite divided by the, that's the adjacent divided by the hypotenuse. Right, and so the adjacent, well, that's just 1. And then the hypotenuse, that's the square root of 2. So we want to get that square root of 2 out of the bottom. It is not considered a proper format. And then this becomes, square root of 2 on the top. Square root of 2 times square root of 2, that's 2. So the cosine of pi over 4 is square root of 2 over 2. All right, now let's find sine. Sine of alpha equals the opposite over the hypotenuse. The opposite is 1. The hypotenuse is root 2. So it starts off the same. So clearly it's going to be root 2 over 2 as well. All right, so we've got cosine alpha and sine alpha are the same whenever we're dealing with the same angle here of 45 degrees, right? Not in general the same, only at 45 degrees or pi over 4 radians. and so let's go ahead and come over here. Let's look at our angle. A couple of things that I want us to note. If we draw this here, and then once we get up to this top point, if you come straight down, and then you come way like this, you note that we do in fact have a right triangle. A right triangle that has 45 degrees. Now, in the unit circle, one of the key things about the unit circle is that the radius is always 1, right? The radius is always going to be 1. And so that means, we've got an x coordinate here, and we got, our distance and our y distance here, right? And so the x and y coordinates will be right. And I want us to think a little bit about cosine and sine, right? Cosine is going to, of our angle, alpha, what's going to be the adjacent divided by the hypotenuse. But what is the hypotenuse? The hypotenuse is 1. So cosine of alpha is x. And this will be true for any angle on the unit circle, right? And again, we're looking at this point right there. And so what about sine? What about sine of alpha? Well, that's y divided by the hypotenuse, and the hypotenuse is 1, right? So put that 1 under there. And so sine of alpha for any angle, right? Not just the one we're looking at, but for any angle, is going to be y. And so all we have to do is say, okay, well, what is x? Well, x equals cosine alpha. What is y? Well, y equals sine alpha. And what's cosine alpha and what's sine alpha? That's right, root 2 over 2. So what does this become? This becomes root 2 over 2, comma, root 2 over 2. Those are the x and y coordinates of that point. Cool. All right. Let's go ahead and look at this other triangle that we have here. We have an equilateral triangle with sides of 1. What does equilateral mean? Equilateral triangle means that all sides have the same length. So we've got a length of 1. Right here we got a length of 1. There, and that's right. We have a length of 1 there. All the same. Now note we've got this line coming through like this. What is going on? You note it is bisecting our base down there in half, right? And so half of 1, hopefully it's obvious, it's a half, right? So we've got, this new triangle formed right here, right? It's got length 1 here, length 1/2 here. We don't know what this length is over here just yet, but we're going to. Let's take a look at the angles for a second, right? And so we're going to call these beta, just so we don't get confused with the other triangle. Right? Beta plus beta plus beta, right? That's 3 betas. If I add all 3 of those angles together, what do I get? I get pi radians, or, if you will, 180 degrees. So what is beta? Beta is pi divided by 3. And what is pi divided by 3? Pi divided by 3 is 60 degrees. And if you look at the other side of our handout over here, you can see that we did in fact look at that angle right there, 60 degrees. That is 1/6 of a turn. All right. So that's good. So let's go ahead and take a look here. This is now, note that is now a right triangle, the one that we have highlighted. This angle here is going to be half of pi over 3, which is pi over 6, right? Pi over 3 times 1/2 is pi over 6. And what is beta? Beta is pi over 3. All right. So far, so good. Now what about this side right here? We haven't addressed that. We're going to use Pythagorean's theorem. We've got our hypotenuse squared equals 1/2 squared plus whatever this side here is. Let's call it little b squared. Now all we have to do is solve. We've got 1 minus 1/4 equals b squared, which is 3/4 b squared. Now we take the square root of both sides and we find that b equals √3 divided by 2. Note that I'm not selecting positive or negative. We're just dealing with a length. Lengths are always positive. Alright, so √3 over 2, that is this length right there. Alright, now let's find cosine of beta. That is cosine of pi over 3. Cosine of pi over 3, that's going to be adjacent over hypotenuse. And so we got 1/2 divided by 1. Well, cosine of pi over 3 is just 1/2. What about sine of pi over 3? Right, so this is the opposite over the hypotenuse. So we got √3 over 2 all over 1. What does that become? That becomes √3 all over 2. Good. All right. Now let's go on to the next one. Pi over 6, right? We're now looking at this angle right there. So cosine of pi over 6. Now we're looking at the adjacent for pi over 6. That's that guy right there. So we got √3 over 2. And then what is the hypotenuse? Well, that's just 1. And note that it comes out the same as sine of pi over 3. Alright, so far, so good. Let's go on to the next one. We're going to look at sine of pi over 6. Right, and so what is the opposite of this angle? The opposite of that angle is 1/2. Hypotenuse is still 1. So sine of pi over 6 is 1/2. Note that, these two are the same and these two are the same. Alright, so let's go ahead and take a look at this. We're now looking at this first angle. That first angle is going to be pi over 6. That is 30 degrees. And so what was the cosine of pi over 6? That was √3 over 2. And then what was the sine? That was 1/2. Okay. And now let's look at this guy here. That's pi over 3. What is pi over 3? Pi over 3, that's going to be, just same coordinates, just flip-flopped. 1/2 and then √3 over 2. Okay, and so that's really the hardest part of this. Everything's downhill from here. If you got this part, the rest of this is just cake. So let's go ahead and just think this through. Think this first quadrant. Right, the radius is always 1. So if I start at the origin, which is coordinate 0, 0, and I travel to the right 1, that means I got a coordinate of x coordinate of 1, and I did not move up at all, so my y coordinate is 0. Right, now let's look at this angle here. That's pi over 2, 90 degrees. If I go straight up and I don't move to the right or to the left, my x coordinate is 0 and my y coordinate is 1. Cool. Alright. Everything else is just downhill from here. All we got to do is kind of fill in these angles. And I'm going to go through, we've already went through how to figure out these angles on the other side of the handout. We're going to go through just a few nice, easy to remember tricks to help you remember which angle goes where. But if you can just memorize this first quadrant, everything else will follow suit. Alright, so first thing on this quadrant 2, pi will always be on top. for those coordinates. And the bottom number here will always correspond with the bottom number over there, right? So pi over 3. And so whatever this bottom number is, you're going to put one less, right? We're one less than pi. One less than a full pi, right? So we took one slice out of the pie. That slice that's being pulled out of the pie, that's this piece right here, right? This piece right here, that would be that last third of a pie right there that we took out. All right. And so on this next one, again, we're looking at the bottom here. Right corresponds with that bottom, so bottom is going to be 4. Take 1 away for the top, so it's 3. Now we look here, right? So we got a 6, so we're going to put a 6 there. Then we take 1 away, so we have 5 pi over 6. All right. Now half a rotation is just pi, right? 180 degrees. We got that. All right, now what's going on over here? Well, we got one full pie, and we're adding a slice right here, right? This is the slice of pie that we're adding on top of the whole pie that we have. And, the bottom numbers are going to correlate again right there. And pi will always be on top. So we got pi on the top, 6 on the bottom. We put one extra piece of pie in, and so now that's 7, right? We're adding 1. Over here we subtracted 1 pi. Now we're adding 1 pi. Okay, and so now we're going to fill the rest of this. We got pi on the top, pi on the top, pi on the top. All right. And so let's look. What do we put right here? Well, it's going to correlate with this one here. So we're going to put a 4. And then we're just going to add 1 to that. And then we look here. We got a 3. So that's the number that goes in the bottom here. And then we simply add 1 to that. So we got 4 pi over 3. Okay. And then this one here, that's a 2. Add 1 to that. We got 3 pi over 2. All right. Now, the last quadrant, it's a little bit tricky, but not really that much when you think about it. Basically in these, we are 1 piece short of 2 whole pieces of pie, right? We're taking this piece out of our pie. So it's going to be whatever the bottom number is, you're going to double it and then take 1 away. And so these guys are either going to, correspond with this one, or you could say it corresponds with this one. Like they're both going to work. And so again, pi in the top, 3 in the bottom. We are 1 piece short of 2 whole pies. So we just double this number and take 1 away. So we got 5 pi over 3. Over here we got pi and then 4 in the bottom. Double it, take 1 away. That's 7. Here, pi on the top, 6 in the bottom. Double it, take 1 away. So we have 11 right there. 11 pi over 6. So that is all of the angles in radians. Right? So we 2 times, then take 1 away. That's what's going on there. Good. All right, so that was really the hardest part of this handout, was getting all that straight. For everything filled out in the first quadrant and then getting all the radians together. The next part is just looking at the first quadrant and seeing what's going on. We note that here in quadrant 2, the x-coordinate is going to have to be negative and the y-coordinate will have to be positive, right? Because we're traveling to the left of the y-axis and then we're going up from the x-axis. And so numerically, the point here will correspond with the point here. Just the signs will be what's different, right? So we have 1/2 over here. So instead of being positive 1/2, it's negative 1/2. And then it's root 3 over 2. And then the same right here. Instead of positive root 2, it's negative root 2 over 2. And then right here, instead of positive root 3 over 2, it's negative root 3 over 2 and 1/2. See how quickly we were able to get that one. Then, of course, -1, and 0. Okay, so not too bad. Let's go ahead and get the bottom part here. Let's go ahead and grab this low-hanging fruit. That's obviously going to be 0 and 1 because we traveled straight down only 1 unit. Alright, so over here in the third quadrant, the x coordinate is negative and the y coordinate is negative. So both coordinates will be negative, but numerically, again, this point will match with this point right here, which also matches with this point right there. Alright, so we put this in. We got -√3/2 and -1/2. And then we got -√2/2 and -√2/2 again. And then we've got -1/2 and -√3/2. Okay, last quadrant. We've got, note that the x's are now positive and the y's are negative since we're going down, right? We're going to the right and then we go down. All right, and so you can either read off the quadrant up here or you can read off the quadrant over here. It's gonna, either one will work for you. So we're gonna have a +1/2 and then a -√3/2, and then we've got √2/2 and a -√2/2. And then finally, we've got a +√3/2 and a -1/2. All right, so real fast, if I asked you what was the cosine of 4 pi over 3, what would you tell me? You would tell me -1/2, right? Why is it -1/2? Because it is the x coordinate of the angle you were looking for. Okay, and that's one way to use the unit circle. It's one way to organize this information. All right, you guys have a good day, and I will talk to you next time.